We all recognize the influence of water on our lives. We feel it when it rains or snows. We taste it on a hot summer afternoon. We experience it while we adventure in its lakes, rivers, and oceans. It's easy to focus on the ways water touches our lives through our senses. But what happens to that water in between those visible stages? The path of a raindrop largely depends on the soil it lands on.
So the precipitation, rain, falls on the soil. First, it's going to infiltrate the soil as long as there is room for the soil to take that water. Then once it is in the soil, if the soil is permeable, then the water can trickle down and percolate or infiltrate all the way through the soil down to the aquifer.
However, if water is restricted from moving into the soil, it can quickly move off the soil and into streams and rivers as runoff, taking sediment and nutrients with it. So we need to understand the characteristics of soil to understand both how water travels through the landscape and how those travels influence the quality of the water. The raindrop is directly affected by the characteristics of the soil it falls on. So to protect our water quality, we must start with protecting the soil quality, so the soil will function well. Not all soil is created equal. Different soils have different characteristics, and those differing characteristics require unique management practices.
Well, soils should not be managed the same way because soils have a lot of different properties. And for example, the clay content or the sand content can really impact how the soil interacts with the weather and the type of crops that you want to grow.
Clay pan soils in the Midwest are particularly difficult to manage because the high clay content prevents the soil from absorbing much water.
So when you have these clay pan soils anyway, since the water doesn't soak in, or I say soak in, but since the water doesn't filter down anyway, like a sandy soil would, we get a lot more runoff on these types of soils anyway, just because there is nowhere for that water to go.
That impacts water quality because if we're transporting sediment or herbicides or fertilizers in that runoff, we're moving them from where they want to be in the field into our surface water systems where we don't want them to be.
Researchers at the Cropping Systems and Water Quality Research Unit in Columbia, Missouri, experiment with different management practices to find the best solutions for different types of soil.
In the research we have here, we have a bunch of different plots. And on those plots, there's different cropping system with different rotation, different crops, different tillage, different herbicides. And of course, we measure what comes out of the plot for making money, like the yields, the grain. But we also measure what comes out in terms of runoff and in terms of the water quality of the runoff.
We look for an area where the field naturally drains, and we put in instrumentation in order to capture the flow and the sample. And here we use the concrete weir. It's called a V-notch weir.
After samples are collected on site, scientists analyze the water quality in a lab. They can then determine which management practices are best for both soil and water.
The better soil management practices lead to improved water quality because if we can improve the soil and the soil health, then we have better infiltration of water, we have less runoff and erosion, and that protects our water resources.
This valuable knowledge is passed on to farmers to inform them of ways they can both produce a high-yielding crop and promote healthy water in their area, a constant need for all people in the days and years to come.